Hi everyone, it's Coach Fred here, and today we're going to be talking about one of my favorite theorems. If you're in my class, we've been talking about it almost all year, so this isn't going to be anything new for you, but I wanted to formalize it, and that's the fundamental theorem of algebra. You can see me, I'm in my cozy winter hat tonight because it's very cold out, and I just got in from walking the dog. And so it's a perfect time for us to be talking about the FTA. So I think it's important for us to be able to read definitions in textbooks and theorems. And you may remember that from geometry that most of our theorems are going to be in the form of if-then. So the fundamental theorem of algebra basically says that if p of x is a polynomial of degree n, which n has to be greater than or equal to 1, with complex coefficients, then p of x equals 0 has at least one complex root. Basically, that means that if I have a polynomial, 2x squared plus 3x, and I set it equal to 0, then it's going to have at least one complex root, okay? But also, the corollary to that says that including imaginary roots and multiple roots, an nth degree polynomial has exactly n roots. So I know this is going to have 2 roots. Now, because complex roots, you already know, come in pairs, it's either going to be 2 imaginary roots or 2 real roots. It can't be one complex root at this point because they always come in pairs. All right, so what in the world does that mean? It just basically means that if here's the polynomial, if I want to solve this polynomial to find the roots, that it's going to have 4 roots. Okay, so it's important to recognize it could have 4 real, it could have 2 real, 2 imaginary, or complex, or it could have 4 imaginary roots. It can't have 3 real and 1 imaginary because, again, imaginary roots come in pairs. Okay, so that's basically what that fundamental theorem of algebra tells me. And so it helps me when I'm asked to solve an equation, I know how many I'm looking for. Now, if it says find the real roots, it's telling me I don't have to find the imaginary roots. There could be imaginary roots to it. All right, I want to review something before we work on the rational root theorem. First of all, we need to know what a rational number is. We've talked about this all year, but I think that we kind of lose track of what all these numbers mean. We have real numbers, we have complex numbers, we have natural numbers, we have integers. A rational number is any number that can be written in the form of p over q, so as a fraction, and p and q are both integers. So examples of rational numbers would be 2, -3, 1/3, okay? Rational numbers are going to could be terminating or repeating decimals. Repeating decimals. Repeating decimals. Whereas irrational numbers that don't end, like the square root of 2, the square root of 3, the square root of 5, so any non-perfect square or pi, we're going to learn about the number e. These are all non-terminating, non-repeating decimals. So it is important to know the difference between a rational number and an irrational number, especially if we're getting ready to talk about the rational root theorem. So the rational root theorem helps us, up until now, if I gave you a polynomial and I said to you, okay, factor it, and it wasn't factorable, I had you grab your calculator to find at least one of the roots with your calculator. There is a way to do that without the calculator. So the rational root theorem is what can help us. So if PQ is in its simplest form and is a rational root of the polynomial equation, so this is just showing me a polynomial equation with integer coefficients, then P is a factor of a sub 0 and Q is a factor of a sub n. All right, again, that's an if-then statement. It's the rational root theorem. What does it really mean? The translation to that is if PQ is a rational root of our polynomial, then P is equal to a factor of the constant term, so A0, like it's set up here. And Q is a factor of A sub n, which is the leading coefficient. All right, so let me show you what I mean. So it says use the rational root theorem to list all the possible rational roots for this equation. All right, so P is our constant term. I'm going to put a P above 2. Q is the factor of the leading coefficient, okay? So Q is 15. So I need to write down all my factors of P, which would be 1 and 2. I need to write down all my factors of Q, which would be 1 and 15 and 3 and 5. Okay, so those are all the factors of those numbers. So all of the possible rational roots would be P over Q and plus minus. Okay, so that means that our possible rational roots could be 1 over 1, so 1, 1/3. Oops, let me start over. So 1, 1/3, 1/5, 1/15, all with plus minus. 2, 2/3, 2/5, and 2 over 15. Okay, so all of these are possible roots to the equation. All right, so let's try. You try. I want you to try B, list the possible roots, and then come back. Okay, so this one was much easier. The possible roots could have been 1 and 3, plus or minus 1 and 3. Okay, so then it says, which of those possible roots in part A are roots? Well, how do we tell if something's a root? Number one, we could use the remainder theorem, so we could plug them in. So I'm going to try that. I'm going to start at the beginning. I'm going to plug in 1. So 1/3 plus 1 squared minus 3 minus 3. So that gives me 1 plus 1, which is 2. 2 minus 3 minus 3. So we can see already 2 minus 3 is -1. -1 minus 3 is not 0. It does not equal 0, so 1 is not a root. All right, let's try -1, okay? So -1 cubed plus -1 squared plus 3 minus 3. All right, so I can see that these are going to cancel, right? And this is going to give me -1 plus 1, which are going to cancel, and that's going to equal 0. So I know for sure that -1, x equals -1, is a root. Now, this is a degree 3 polynomial, so it means there could be more roots. Now that I have that one root, I'm going to use synthetic division, 1, 1, -3, and -3, to see if I can get a depressed polynomial that I can factor to find the other roots. Now, with 3, I could have just plugged 3 in as well, but I decided to show you the other way that you could do this, okay? So I can do synthetic division. We know we should get 0 because we know -1 is a root. And so this tells me that x squared minus 3 is the other factor. So that's actually not going to give me a rational root, is it? It's going to give me, if I set it equal to 0, it's going to give me x squared equals 3. So it's going to give me an irrational root, a plus and minus irrational root. So those are the other roots. So -1 is only the rational root. Plus or minus root 3 would be the irrational roots. Okay, we're going to practice this tomorrow, but again, it's just a way for you to figure out what could be possible roots and using some theorems we've already learned using the remainder theorem to tell if something is a root. All right, hopefully that was a helpful video. Have a great day.